Hello, folks. How's it going? This is Rational Science, the only site on the internet that does physics rationally. Everybody else does mathematics. They move concepts around. Today we're going to be talking a little bit about extinction, our countdown to extinction, topics related to that. We're going to do physics. We're going to do very exciting, the most exciting subject you can think of, direction. You might say, Bill, can't you think of anything more exciting than that? Yeah, it's quite an exciting subject, so stick around. Then we're going to look at something that this our science critic came up with. We're going to look at something that he criticized, and we're going to address that. And finally, we're going to open up the floor for questions. People who asked questions and made comments since last time. Okay, let's go with the extinction segment. This is the first topic. Okay, and here it is. Fellow says, nationalism is a religion. Okay, yeah, I said that the other day. He agrees, okay. But just because it is a religion does not mean that we can't feel the way that we do or advocate for the people who we love, okay? I don't like seeing people who look like me and think like me get disempowered. So I'm going to resist the changes that are causing this to happen. Yeah, I guess we were referring primarily to the war in Ukraine and whether you should take sides, that sort of thing. This is because I love the people who I believe to be disempowered, or because it is in my interests. And let me tell you, I feel for him because I used to be like that myself, long time ago. Fortunately, I came out of it. My grandmother one day told me, never, never get into politics. And I did. In fact, I got into politics at a very early age. I was about 15 when I started taking a big interest in politics, would read the newspaper every day, and eventually got into communism in my 20s, early 20s, and that lasted till I was about 36. So it lasted from 15 to 36, we're talking about 21 years. Took me to realize what politics is about. Slow learner, okay? Took me more to get out of atheism. I used to be an atheist. I came out of an atheist home. You know, we talked atheism every day at home, Bible study. And it took me a while to get out of that one as well. I had to think those things over. So yeah, it takes a long time. And all I can tell this fellow is that, you know, there's very little you can do about stuff out there. You know, one thing is like me, I got involved. Okay, got involved in politics, actively, you know, involved. That's different than when you are at home, you know, and just watching TV, reading the news, and getting all excited for something that happens on the other side of the world. And you get excited, and you take sides, and say, this is wrong, this is right, and this, you know, and you get all excited about it. Maybe you don't even sleep at nights. My recommendation for all those feelings is, you know, you want to solve the world's problem, very easy. Turn the damn TV off. Turn the radio off. Don't read the news. You'll solve all the world's problems. That is the solution. Okay, so here are some situations here. I want to see if this fellow can recommend something to me. You know, he feels for people out there. He wants to get involved. He wants to vote maybe, you know, for a different candidate. Okay, and so here it is. Okay, we have on the top, we have Armenia fighting against Azerbaijan. Okay, and they're fighting for that little orange area there that you see. It's called Nagorno-Karabakh. Okay, so which side should you take? The one with the half moon, the quarter moon there on the right, the green ones, or should you go with the blue and red ones on the left? And how about the one on the bottom? You got the Saudis, the ones on the right, with all those cannons, all that good hardware. And the guys on the left are the Houthis, who are these who are these people? Okay. Yeah, the Houthis, and so they're fighting Saudi Arabia in Yemen, and that's what you see there, that map there. So who should I take sides with there? I mean, should I be with the Shiites or with the Sunnis? I mean, what do you think is a better bet, or who do you think is in the right? Because we're talking here about, you're going to take the right side, and the right side, not always the winning side. It apparently, right? it's it's a side that deserves to be backed. And there's always two sides to all these things, and people take sides immediately for stuff that doesn't even involve them. It's on the other side of the planet. You don't even know where it is, and you say that's wrong. I want to get involved, and maybe even pitch money, maybe vote if you can or whatever. And another thing is if you go personally and you get a weapon, you start killing people, it goes on the other side. Turns out that your brother's fighting on the other side, like in Ukraine, and maybe he was recruited by the Russian government and sent to the front. He doesn't agree, maybe, but he's forced to go to the front because he's a soldier, and they put him a gun in his hands, go fight. And you go on the other side because you don't agree with the Russians, or you go on the Ukrainian side, you go with a gun, you kill your own brother. Great. So look at some of those situations. It's easy to take sides, especially from far away, and kind of eat popcorn while you watch the game. Another thing is to get involved, and then should you get involved anyways? Does it concern you? So this I can tell you. My grandmother said, "Never get into politics," and I did. Okay, she was right. It just took me a long time to figure that out. Okay, here's another situation. Here you have the Israelites, and they're fighting the Palestinians. And whose side should you take there? I mean, maybe the Palestinians are guerrillas, they're terrorists. Maybe the other guys are abusing with their apartheid. Whose side should you take? Does it concern you? Are you a Jew, or are you a Palestinian? Whose side should you take? And this war's been going on at least, I would say since the Balfour Declaration, Lord Balfour there, 1917. They started allowing Jews to have their homeland. And I guess that's when the whole mess started. It got worse in 1948 when Israel became an official country. And little by little, they've been expanding and pushing the Arabs out. A lot of people say it's a United States fifth column. That's all Israel is. And the other guys on the other side, they throw stones at the tanks. You say, yeah, that's what they should do. And so if the kid, a 13-year-old kid throwing a rock, he gets shot, killed, are you going to grab the stone and throw it, and you throw it at the at the tank? Is that what you want to do if you're on the Palestinian side? Okay, and so here we arrive at the Ukraine war. Here we have Bugs Moran against Al Capone. Okay, whose side should you take? Should you go with the blue side or the red side? Okay. Well, I don't know. Again, maybe you might be killing your brother over there. You got people there who are in that war that don't want to be in that war. They're forced to be there. And probably, at least, I would think, maybe the majority, or at least I would say half of them, don't even want to be in there. Especially, it's easy to say it when you're at home, but when you see those bombs just flying close to your ear, you think a little differently, So you got to be in that place. And the question is, what's it to you? And what I mean by that is whatever's going to happen is going to happen anyways, with or without you. That's what I mean. So that, for you to get excited for something that happens on the other side of the world and that you have no control over actually as an individual, don't get involved in politics unless you're going to be a politician. I mean, if it's your career, that's different. But and you go up the ranks in a party, a political party. Well, yeah, make money and influence people and change the laws. Yeah, that's great. But if you're just a passive, guy who's at home watching the TV, and you get all excited for the stuff that happens in other parts of the world, just turn the TV off. You'll be okay. You'll solve all the world's problems. Okay, and here's another side to that. Okay, fella says the following. He says, I have money in Raytheon, so I will benefit from a nuclear war. Does anyone want to buy my position? And I don't know if he's talking seriously or not, but he's got a point there. There's a lot of people who are making profits. And this is not a secret. This is not new anyway. It's always happened. People profit from wars, and so keep that in mind. And in fact, here, let me rub that in a little bit. Here's one bit of news that came out this week concerning this, right? Trump blasts Biden over tanks for Ukraine and calls for an end to crazy war to repel Russian invasion. Why did he do that? Well, as President Biden has led the push to help Kiev, Trump and his MAGA allies have repeatedly demanded the U.S. stop spending big bucks, right, to help the embattled nation. And there you have a representative echoed Trump's remarks, calling aid to Ukraine a corrupt slash fund without elaborating. In other words, here you might be helping corruption if you send your money over, if you fight for this cause, whichever side you're on, doesn't matter. You may be fighting for someone else who's going to profit from it. and you're just a sucker who's doing the work for them, because of your ideals. Okay? And here's the final pitch on that one, and that's that Zelensky sacks more than a dozen top officials amid allegations of corruption in Ukraine. And what were they doing? They were accepting bribes. Okay, so you send these tanks, that's also famous, the $500 hammers they sell to the army. And they sell these tanks, all this hardware that cost a lot of money to build, and they just give it away kind of, or put it on the tab, And these people on the other side, you got corrupt officials who, say, hey, I can make money out of all this. And they're not fighting the war. They're not the soldiers on the line. They're the guys, in their homes, their mansions, and they're making money. And here you're fighting, you're rooting for the people who are going to win, and it's not going to be the soldier who died. It's going to be the guy who has the power over there in the government. So in a way, who are you fighting for? So think about all this when you take sides. Who benefits from you taking sides? Okay? Fellow says he doesn't believe in nuclear weapons. He says the following. He says, Hiroshima and Nagasaki show that you also do not know what you are talking about and buy into the hype about nuclear war. Because I was talking about the possibility that, they could, Ukraine war could lead to a nuclear exchange, right? And I'm saying that once they press one red button, they're going to press all the red buttons. I don't think that you can stop that, okay? Anyway, it says, the science says both cities should have been uninhabitable for 1,000 years after nuclear war. Yes, yet their population doubled in 20 years after being nuked. Hiroshima now has 9 times its 1945 population of 137,000 to today's 1.2 million, okay? How about Chernobyl, Bikini Island? Both of these places are full of life like never before. Your fear of nukes ending humanity is baseless. Okay, all I can tell you is that, first of all, I don't think it's nukes are going to end the world. If anything, nukes are going to be part of the process. And that's likely at the end. They might press the red button when they don't care anymore about anything. It could happen. But that's not the cause. The cause is going to be the overturning of the population, of the ecological pyramid, meaning that no one's going to produce food. And it won't matter how much money you have, there won't be food to buy. Whoever's got food is going to keep it, hide it, and there's going to be a killing of not Chinese against Americans or Russians against South Americans. Americans. No, it's going to be your neighbor. That's the guy you're going to fear wherever you're at. That's the guy who's going to come after you. Okay, local people. And then the other issue is, some people don't believe that there are nukes out there and that we've ever thrown nukes, killed people, and so on. This guy was talking about Hiroshima and Nagasaki. Okay, and here are some pictures, and I guess he doesn't believe that this ever happened. Here you see him. Here's the Enola Gay, the airplane that took the bomb down there to Japan. Okay, they dropped it over Hiroshima the first time, second time over Nagasaki a few days later. Okay, they bombed the hell out of people, and the first one there was not the original shot, but this one is. This is the only one that survived from what happened that day. Okay, and then here you have another vision of what came after. This is what was left. Okay, you can see the pictures. And this fellow believes this was probably made in Hollywood, all of this. Here you have some Japanese just going to work a few days later, and he says, well, no one should have survived. There should have been zip amount of people there. And you can see that they're walking, and this is the city that was left after they bombed Hiroshima. Okay, so just keep in mind these are part of the historical record of what actually happened in those days. But this guy doesn't believe it. He thinks that all of this was probably made in Hollywood, just propaganda. Maybe, they got some actors to walk there and whatever. And he doesn't realize that he's got the solution in his own hands. He says, look, there's Chernobyl, and there's Bikini Island and so on, the Bikini Atoll there. And yeah, people survive and live in those places. And so maybe it's the other way around. It's not like he thinks that everybody should be wiped out and no one can live there for 1,000 years. Maybe it's the other way around. Maybe after the bomb is thrown, some people can live there. Okay, so keep that in mind. Maybe it's not like you think it is. Okay, so I've been to Alamogordo in New Mexico. I went in that region many times, going through Las Cruces and other places there. And hopefully I don't get cancer, from going through from the site where they threw the first nuke in 1945. So I don't know what to tell you, guy, but no, if it were true what you say that nobody can live there anymore for 1,000 years, we're all in trouble already because they've thrown some nukes even within the United States. So anyone who lives nearby there, I guess, should look at his cancer, his radiation, all that stuff. Not necessarily so. Okay, and so here are some of the images from some of the survivors. Over there, you can see this guy's ears, if he's got ears left. Okay, and this is a woman, her clothes got stuck to her skin so that it just penetrated and marked her. You can see some of the consequences of the radiation. And this guy probably believes this is just, all faked, all done for propaganda purposes of some kind. And I don't know what to tell him. It's like those people who say, well, if I didn't go to the moon myself, I don't believe that anyone went. And so they don't believe that humans went to the moon because I have no way of verifying that and I haven't gone there, so it's all a hoax. Okay, what can I tell you? And in another issue, I found out today, in fact, and it's a law that was passed about 6 months ago, and I was not aware of it in Japan, okay? And it was because a girl took the ultimate decision, okay, wrestler, and her fans or enemies, I guess, said a lot of bad things about her, and so she took the ultimate decision. And because of that, they're going to stop people from saying bad things on the internet, okay? And so this is it. It says Japan passes bill making online insults punishable by jail time in wake of Terrace House star's death, okay? So this girl did the ultimate. She was only 21 or 22 years old, And now that we have laws that say, be careful what you say on the internet. And so I'm going to tell all the people who come to this channel, be careful what you say about me, okay? Because I might do the ultimate too, and you're going to be in trouble. So watch out what you say about my mother, okay? Okay, we live in a new world, so what can I say? This is the world we have. They say it's free speech, but you're not allowed to yell fire in a movie theater. That's more or less the situation. Okay, so even in jest. Okay, let's move on to the real subject of today, which is um, direction. Direction is easy. Look, there it is. There, I point right, and I have direction. Right, we're done. That was it. See how easy it was? So, how did this subject come about? Well, we have a couple guys that question this. And this is what I put on the last couple times, and that's the Universal movie. And why is this movie interesting or important as a tool? Remember, it's a tool, okay? And what it is God stops the universe. He stops the watch, the clock, the universal clock, or the heavenly clock, or the universe just stops on its own, okay? Nothing moves anymore, not even an electron. So everything stops, all motion stops, okay? That's the situation here. And it's a good tool because then we can find out what actually exists. And what exists can be shown in a single frame of that movie. That should show us what exists in the universe. If we had God's eyes, we would be able to see everything that actually exists, right? And that's the idea here, is to visualize, like if we had God's eyes, what actually exists out there. For that, we don't need any motion. We don't need two or more frames of the universal movie. We just need one slice of time, or cross section of time, as I call it, or no motion, any way you want to visualize or imagine it. We stop motion in the universe, no more motion, no more time. Whatever's there is what exists. You're supposed to visualize a static universe, or what I call a frozen universe. Okay, that's the idea, the tool that I call the universal movie. Okay, so one fellow says the following. He says, explain this mechanism with a paused movie. Well, the issue is that it's a tool. That's all it is. There's nothing to explain. It's just, I want you to make believe, what do you call it? Thought experiment? Make believe, go through the motions of believing that you can stop the universe. Everything in the universe is standing still. Nothing moves. Try to visualize what is in there. Not only the visible stuff, but also the invisible stuff. Remember, you got God's eyes. Okay, what do you think is out there that you cannot see or touch? Okay, that's the idea behind the universal movie tool. Okay, and another fellow says, so does Bill think an instant or durationless moment universal frame is a coherent notion? And again, it's just a tool. It's used to identify what the objects that are there are. What is out there. Okay, and part of the reason is because of this. Let me show you this. Part of the reason is this, or the purpose, right, is that a lot of people confuse static with dynamic concepts. They bring in things that require at least two frames of the movie, two locations, as we talked about last time, and they think they're talking about a single frame, what's in one frame. And there you have some examples like, plasma, ether, field, and energy, and so on. All those are dynamic concepts. Okay? They're not objects. They're not standalone physical objects. You cannot point to field, okay? Because field is something in motion. You cannot point to plasma. Plasma is something in motion. And I cannot point to ether because ether is vibrating, and so on. All these are dynamic concepts. You need at least two frames in a movie to conceptualize any of those. On the other hand, you have some static concepts that you can visualize and define and imagine in a single frame, and that's distance, location, and existence. And the one we're going to talk about today, which is direction. Okay, So what does the universal movie allow us to do? Identify the objects, define the static concepts, okay, and differentiate those static concepts from the dynamic ones. That's the purpose of the tool. It's just a tool, it's just a handy tool to be able to relate to what is static, what can be visualized in a single frame that does not require any kind of motion or time or whatever, any kind of movement. Okay, so what's the problem? Well, here it is. We consider direction a static concept. You can see it's under the static group, not under the dynamic group. Okay, but the establishment, the mathematicians, they believe that direction is a dynamic concept, and it's defined as a dynamic concept. And everybody has this notion, oh yeah, go in that direction. And the direction to get, what are the directions to get to City Hall? Well, you go this way and that way and that way and that way. That's how you get there. And so people have this notion that direction is the dynamic concept when it's not. We put it under, in the universal movie, we put it under a static concept, a group of static concepts. And that's where the problem starts, okay? And it gets quite complicated here, okay? Okay, so here's the definition that you find out there. This is, I think, from the Wikipedia. And you look up orientation there, and it says direction is a synonym of orientation. Now, both orientation and direction sound like, static concepts. In fact, the first line that you'll read says something along the lines that says, the orientation, and I put direction in there because it's a synonym, and it's also put in there as one of the possibilities, so I haven't cheated here. The direction of an object is part of the description of how it is placed, okay, in the space it occupies. So now they're talking about you standing in a given location, and that sounds like a static concept so far. So far, so good. But then you'll see down the line, you'll see more specifically, it refers to the imaginary what? Rotation that is needed to move the object from a reference placement to its current placement. Now they're talking about direction being something that moves, that has to do something with rotation. And there you see it's a rotation may not be enough to reach the current placement. It may be necessary to add an imaginary what? Translation, another dynamic concept, called the object's location or position. Well, how does translation relate to location or position when translation is a dynamic concept and location position by the mere words, they represent static concepts. And what they're referring to is ordered pairs there, you see on the bottom right. That's what position is in mathematics. Okay, so ordered pair is how you get there. Okay, and you go 6 steps to the right and 4 to the north, and then you get to the position. And so they're talking about the translation, the fact that you moved from 0, 0 to 6, 4. Okay, so that's how it becomes a dynamic concept. And this is a synonym of orientation. Direction is a synonym of orientation. So under those definitions, they're dynamic. But then again, they come back to this, the location and orientation together fully describe how the object is placed in space. That's again, direction equals static concept. And then again, they say the orientation of an object does not change when it translates, and its location does not change when it rotates. And you can see the pictures they put in there, they all talk about motion. So what is direction? I thought we all knew what direction was, but these people are saying that direction has something to do with motion. It's a dynamic concept. So let's investigate further. And here you see some of the sites out there. Okay, and they talk about angular acceleration. And you see in those sites, it says direction of rotation, direction of motion. Well, what direction is the rotation in? I mean, in what direction if it's changing the direction constantly? So can we talk about the direction of a rotation, the direction of circular motion? Or irregular motion. That's not on a straight line. So what is this direction that they're talking about if the direction is constantly changing? And yeah, that's exactly what they're talking about. They're talking about a change in direction, not about direction. Okay, so change is a synonym of the word motion. And so, yeah, when you say change of direction, you're talking about the motion of direction, of change, of a changing, constantly changing direction. And the change has nothing to do with the word direction. That's the point. Okay, either direction is change or direction is direction. Static concept. But to say change in direction, well, we have a little bit of a problem there, because are we referring, when we use that word direction, are we referring to the static concept direction, or are we referring to the change? That's the issue. Okay, so we go to the Oxford Dictionary and see what they have to say. And it says, world's leading dictionary published, sure. Says direction, a course along which someone or something moves. The course which must be taken in order to reach a destination. And a point to or from which a person or thing moves or faces. Faces I can accept, but moves, that's something else. Then you have the dictionary.com says the line along which anything lies, faces, moves with reference to the point or region toward which it is directed. Okay, so when you look at direct, because they use directed to define direction, which is already a no-no, you can't use a synonym. But you look up direct, it says to guide or show the way to a place. Direct, to point, aim, or what? Send toward a place or object. So in the best of cases, direction refers to a static and dynamic concept. In the worst of cases, it just refers to the dynamic concept, which is what most people have in the backs of their minds when they think about direction. Direction are kind of like the instructions on how to get there, like position, the ordered pair. It's how you get there. Okay, that's more or less the notion they have. And the other thing you should keep in mind is, in mathematics, they only deal with dynamic concepts. They don't have any use whatsoever for static concepts. That's where the problem begins. That's why mathematics became science, a synonym of science. And why science only describes, because that's all that mathematics can do. And what do they describe? Well, they always start the movie in motion already. It's already a film strip. They never start at square number one to point to the objects. The Universal movie, a static frame, that's not what they point to. They can't, because mathematics has no use for that. That's the issue. And that's how, mathematics became a synonym of science and vice versa. Okay, so here we have a famous concept of mathematics that uses direction. Okay, let's find out what this is. It's called velocity. Okay, and it says speed and direction. Speed is magnitude. It's a quantitative concept. Direction, on the other hand, is a qualitative concept. So they're going to mix a qualitative concept that has nothing at all to do with mathematics, and they're going to blend it in there with speed, which is a magnitude, which is a quantitative concept. But we have more than a little problem here. We have a second problem here, because velocity is for a single point. So when you have a single point, what is the direction? Okay, here you have it. Okay, velocity is 5 miles per hour. Okay, we all understand that. What's the direction of that point? If it's a single point. I mean, if you have an elephant there, you say, well, okay, the trunk is pointed in that direction, and it was moving in that direction. But when you have a single point, right, because velocity is only for a given point, okay, what's the direction? Okay, how can you conceptualize direction for a single point, meaning location? Okay, that's the first problem. Okay, and here you have the Earth going around the sun, okay, and they say, well, it travels at 30 kilometers per second around the sun. Okay, no problem. And they say, well, it's accelerating. And you say, hold it, I thought you just said that it's 30 kilometers per second. That doesn't seem like an acceleration. It sounds like a constant speed. Yeah, it's accelerating not because the magnitude increased, but because the direction changes. The qualitative component of acceleration is what um, changed. Okay, and so here you see why we need to define this notion of direction and realize that it has nothing to do whatsoever with mathematics. The direction part is the physics part. The magnitude, they can keep that. That's mathematics. But the direction part, that belongs to physics exclusively. Okay? And so, yeah, you look at acceleration, it's a change in velocity and change in direction. And there you see the definition, okay? An object undergoing circular motion experiences centripetal acceleration, okay, towards the center, right? And in circular motion, centripetal acceleration refers to changes in the direction of the velocity, but not its magnitude. So we have the component known as direction right there at the bottom, okay? The qualitative part is what changes, and because that changes, they call it acceleration, which everybody and their mother, they usually relate acceleration as something that is increasing in speed. I accelerate. If you decelerate, well, you decrease your speed. So everybody thinks of speed because that's on a straight line. But when we have a curves or a curvilinear path, now they look at direction. You can have a constant speed, but it's the direction that they say compels the acceleration. Okay, so this is what you got to keep in mind. Direction, now they're introducing something that does not belong in mathematics at all. Okay, and they call it acceleration, which acceleration seems to imply that they're referring to an increase in speed, deceleration being the decrease in speed. Okay, so keep all that in mind. Okay, but then we run into some other types of problems. Here's one of them. Okay, Stephen Hawking, a guy who died a few years ago, says, goes in there, I'm not going to read all this. He says, in other words, the laws are the same in the forward and backward directions of time. Forward and backward directions of time? What direction is that? I mean, I guess my forward direction is this way, right? But yours, you're coming in opposite direction. So which way is time going? Is it going my direction, my forward, or your forward? So they use these terms, forward direction of time, and people just swallow it. They don't catch these things. They just goes through one ear and out the other. And yeah, we have a problem there because these people are talking about the flow of time and that you go forward in time. And it gets worse. Here you have Mr. Brian Greene, and he says he goes forward to the future. Okay, he travels to the future. Okay, so time always goes towards the future for some reason, And they talk about whether, they do all kinds of analysis in the religion of mathematics about time, whether, it flows in the reverse direction and so on down the line, And they talk about flying to the past or going to the past, say, kill your grandfather, that kind of thing, So we get to all this language stuff. It's all related to language. Some of this language does not belong in mathematics at all. Some does not belong in physics. Like time does not belong in physics at all. We have no use for time, okay? Because in physics we have to explain, and time can only describe. We have no use for time. It doesn't explain anything. Okay? I cannot explain anything by saying that the pencil, fell to the floor in so much time. Okay, that's a description. I need to know what caused it. That's what physics is about, not how fast that thing moved. Okay, so what do we do? Well, in science and physics, we have to start with language, what people call semantics, word salad, word wizardry. No, it's called, or semantics, these terms that they use to brush aside all this because it bothers them. They want to use the word field. They want to use the word plasma. They use electricity as a physical object. Just stick your fingers into the outlet and you'll find out if it's an object. So that's how they determine if it's an object. They touch electricity, so it gets a shock, and they say, "Oh, that was an object. That was the thing that hit me." Okay, so we start with language. Okay, here it is, language of physics. That's what we're going to do. We're going to learn some language of physics that we need to especially define what direction is. And so in science, we do not do experiments, we do not use math, and we do not make predictions. Why? Because science is about explaining rationally. That's what science is. Science, we explain. That's all we do. Okay? Objectively, like we said the other day, okay, we have to give an objective explanation for the purposes of physics, right? Of a mechanism, of a cause. Do you believe it? We don't care, because belief has no role in science. I'm not here to convince you. I'm not here to persuade and convert you. I'm here to explain a mechanism so that you understand it. Then you go on your merry way and think whatever you want. You just need to know or understand what I'm trying to convey to you. My theory of what I think the mechanism is of gravity, of magnetism, of electricity, or whatever. So I explained to you a mechanism, you understood it, that's the end of science. Whether you believe it or not, whether I like it or not, that's irrelevant. In science, that's religion, that's belief, opinion, okay? So, physics, rational explanations of causes and mechanisms. That's what physics is about. What the mathematicians dismiss as philosophy, because they cannot explain. That's why they dismissed it and got it out of science. And so today they say, well, that's not science, that's philosophy. Go to the philosophers. You go to the philosophers, they send you right back. They say, well, we get our cues from the mathematical physicists. And so whatever they teach us, that's what we analyze. So you go to the philosophy, like you go to the Stanford Encyclopedia of Philosophy, and they talk about the same exact nonsense that the so-called physicists, quotations on that, mathematical physicists, what they talk about. So no one's rational. Whether you go on one side of campus or the other, they're all irrational. Okay, so what, if you're going to explain a mechanism, you're going to need objects, okay? And the most basic of words in physics is the word object. Thing, body, entity, figure, whatever you want to call it. Those are all synonyms, okay? We use the word object. What is object? That which has shape. People say, oh, Bill, please define shape for me. No, we don't want to define shape. Sorry. Say, well, I got you there. I got you there. No, we don't define shape because it means that you didn't understand squat of what the problem is. The problem is not the word shape. The problem is that if we do not have that definition there, we're going to go with a default. And the default is see, touch. That an object is that which you can see or touch. And if you go with see or touch, those are verbs. Verbs require two locations of an object. And so it's already, so you can't use those, you can't use a verb to define the word object. Okay, so, and besides the fact that you need two objects to do see or touch anyways, it's got to be something that sees or touches something else. So there are many problems with the see-touch criteria, which is the one everybody uses because everybody wants to go and do an experiment in the lab to see and touch that which is invisible and intangible. So we don't know how they're going to accomplish that with any experiment. That's why experiments are not part of science. You can do all the experiments you want, no problem. But when you come to the conference, we want an explanation, not your stupid experiment. Okay? So see touch is the criteria if we do not go with shape. That's the issue. We don't have to define shape. We just have to know the difference between shape and see and touch. That's it. Okay? Or any of the other, some people say it's that which has mass, volume, whatever, same thing. You got to know the difference between shape and all the others. As long as you know the difference, we do not need to define the word shape. Okay. Besides, the devil's advocate, he's gonna, he's gonna just go, and show you that you need more and more words to define the previous word and the previous word and the previous word, and that's what they want. They want you to go through the whole dictionary. Okay, and just to show you that, see, eventually you cannot define a word perfectly. That's their argument. Now, in science, we have to. In physics, we cannot leave the conference room. There's 8 billion people here in this conference room. We cannot leave. The doors are shut until we define the word object, because we cannot do physics without understanding what an object is. Okay, what the word object, what the definition of that word is. So we go with the word shape, and that goes against see and touch. In other words, against experiments. We don't do experiments to see or touch that which is invisible or intangible, and hopefully there are invisible, intangible objects out there mediating gravity, magnetism, because otherwise you're doing your explanation with black magic. You're saying there's action at a distance. Yeah, by what? Angels, God, black magic? That's the issue. So object and shape, they're static concepts, both of them. And math and math viz, they don't use objects, okay? And they don't use static concepts. They have no use for static concepts. All of mathematics and all of mathematical physics deals with dynamic concepts only, exclusively, okay? Okay, let me get this one out of here. So here, let's go with one static object, an object that we're going to need to define direction, and it's the word line, okay? What is line? Well, line is an object. It's a figure. And there, you can see it's got shape. It's that blue one, violetish one there, okay? It's an elongated rectangle. That's what a line is, okay? And that's objectively what's in front of your eyes, okay? So what do you see there? You see some kind of elongated rectangle? That's a line. We call that a line, okay? How many dimensions does it have? 2. It's got width and height. You can see that I took a little piece of it and expanded it. You can see it's got height and width, and it's got 4 edges. I show 3 there, one on the top, one on the, my right-hand side, okay? And one on the bottom. And you should imagine on the other side of this stick, right, the 2D stick, there's another straight line, another edge. So we have 4 edges. The line is straight, and so are the edges. Okay, we're going to get to that in a second. And the line is continuous. Okay, what is continuous? Made of a single piece, conceptually made of a single piece. Okay, it's not made of parts, not made of little pieces. It's not mereology. It's made out of a single piece. It's continuous. Okay, and it's finite. Like any stick, like this one, more or less. It has a beginning and an end. Otherwise, it would not be an object. On the other hand, you can see the line of mathematics. It's the infinite line. And that's not an object. That's an itinerary. Okay? It's made of points. And what are points? Locations. So they're talking about an itinerary. And it goes from negative infinity to positive infinity, because they're really trying to put numbers in there. And they say each one of those points is a number. Well, aren't there 2 numbers? Are there more numbers between any 2 numbers? Yeah, put as many as you want. We can put infinite numbers between those as well. Chop it up as many pieces as you want. Okay, so we're talking about not lines. We're not talking about a stick that belongs to physics. We're talking about an itinerary, and again, it's not an object. Okay, an object is a line. The line is the one that you see on the top, not the one you see at the bottom. Okay, so let's make sure we understand that. Okay. Okay, let's move on here. And here we have some definitions that we're going to need. First one is the basic concepts used in physics. The first one is straight. What do we mean by straight? Well, straight, first of all, is an adjective. And it is a synonym, essentially, of direction. In other words, it's the adjective version of direction. Okay? But straight is an adjective, whereas direction is not. Okay? In common usage, in ordinary speech, direction is a noun. It is not so in physics, because only objects can be nouns in physics. You cannot talk about direction per se in physics, like saying the direction did this or the direction did that. You cannot use it in those terms. It cannot be the subject of a sentence in physics where you're explaining a mechanism. Okay, but it's a property, it's an attribute. You have attributes like shape, which are intrinsic, and you have attributes like direction, which are extrinsic, which involve other objects. Okay, So we don't have a word for that because no one ever figured this out. That's why. Okay, so straight is an adjective, and it's used to qualify objects. All adjectives are used to qualify things, objects, okay? Entities, figures, okay? Straight edge, what is that? Well, it's conceptually 1D. Conceptually, I underline conceptually or highlight conceptually because edge is not a physical thing, okay? So you cannot say it's got, that the edge is a thing. What the edge is a concept that serves as kind of like a limit to a thing, okay? So it's a conceptual, but it's conceptually 1D. Objects can be 1D, 2D, 3, well, not 1D, but 2D, 3D, but edge cannot be any D, okay? No dimensions can be applied to edge. But it's conceptually 1D. I hope you understand what I just said. It's kind of like the line of mathematics, okay? Straight edge, again, you could say it's the synonym of width. Okay, in that sense, you could say it's a dimension. I'm going to use the word edge for straight edge from now on. So anytime I say edge, I'm referring to a straight edge. It's continuous also. What is continuous? Made out of a single piece. Not the edge of your balcony. That's not made out of a single piece. Okay, I'm talking about the edge that we're going to use in physics when we point to an object. Whatever edge, whether it's straight or curved, that edge is conceptually made of a single piece. Okay, it's like the object itself. The object is made of a single piece. We don't care how many atoms make it or if it's made of points or any of that. Mereology doesn't play a role in science. That's nonsense invented by the philosophers, so-called philosophers. Okay, and continuous is opposite of segmented. Segmented means chopped into pieces. Okay, and you can maybe relate those people who do some electronics or maybe even programming. You have their analog versus digital. That's more or less the notion that we have there. Okay, segmented means made of parts. On the other hand, we have axis. An axis is a concept. It's not an object, okay? It's not a stick, really, but it's a concept that's not equal to edge, okay? So edge, axis, and direction are not synonyms because they're used for different things, okay? And the notions we have behind these words. Edge has to do with the limit of an object, a border kind of thing, right? Whereas the axis is, around an imaginary stick. You can place a line in there if you want, because that's also properly visualized. But the issue is that it's a rotation place, a place around which something rotates or spins. Okay, so we use these things for different things. We don't use the edge for that. Okay, sometimes the edge could coincide with an axis, but not necessarily so. Okay, so these are the notions that we need to learn in order to zero in on our definition of direction. So it wasn't such an easy concept to understand, especially when the mathematician thinks that's something in motion. Okay, so here, these are the most popular notions that we have today of what a direction is. The course along which something moves, aims, or points, a line leading to a place or point, or along which something lies, aims, or points, okay? To aim or move along a line, a position to which motion or another position is referred, and the alignment of 2 points in space or their mutual angular position or orientation. These are the general notions we might have out there. And why do I mention these? Because from there we are going to try to see if we can extract the main notions that we're going to need to define this difficult word called direction. Now, I just want to point out something that people say, well, direction, that's so simple. Why haven't we zeroed in on this? Why haven't we zeroed in on the word object, another simple word? Why haven't we zeroed in on the word exist, another simple word? And I'll tell you why. Because it's the simple words which are the hardest to define, the ones that form your foundation. Okay, that's why. Okay, and aside from the fact that we have the wrong people doing it, which are the mathematicians, which have no use for static concepts. Okay, so all these things you got to keep in mind. Okay, so here's what we might need to define direction, and it's two objects. You need two objects to define um, direction. And the fact that you need two objects, remember what a concept is? It's a word that invokes two objects or two concepts, or one concept and an object treated as if it were an object. Okay, so you need two things, and that's what a concept is. So in that sense, direction is a concept. You need two. Facing, you have two objects, and like my finger, okay, and you say, well, here's a surface, right? And whatever I point to, the moon, a stick, a tree, a rock, whatever I point to, that's got a surface. And so there's a face of that thing facing me and my finger facing it. And we establish some relation there, and we call that direction. So we need facing, or the notion of facing is involved in there. Okay. Aim, we have to aim, right? Before you point, you got to aim. Or pointing is aiming, you could say. It's got to be straight, not rectilinear. See, some people use the word rectilinear. Rectilinear is what we use for motion, right? And we say rectilinearly, something is moving rectilinearly, parallel to a straight line. Physics, straight. Rectilinearly, well, that's also physics. You're going to talk about curved motion versus straight motion, right? And so rectilinearly, you could say parallel to straight motion. But what all these people use is straight path, straight motion, straight itinerary. No, the word is rectilinear, okay? You can't use the word straight. You can only use it for objects, not to qualify verbs, not in physics. In ordinary speech, you can. In mathematics, you can, not in physics. Continuous, single piece. It's got to be continuous. You can't chop direction into two pieces or into several pieces like the mathematicians do. They have this dotted line, infinite line made of points. It's all chopped into points, locations, right? And they say that's a line, and that line, that one that I just defined, is direction. No, because that's an itinerary. Okay? We don't use itineraries to define direction because nothing is moving. Okay? And here you have the definition. Okay? Direction, a line between two objects. What was a line? It was what the mathematicians call line segment, but it's not even that, because this line is not 1D, okay, it's 2D, okay, and that's what we have in direction. Because we can visualize a line, we cannot visualize a 1D, whatever the mathematicians call a line, okay. You can also say that direction is a straight edge, okay, if you're going to use that as more or less a synonym. There's two others I sometimes use. I'm not too confident of those, but I'll put them there anyways. Mutual facing of two objects, and direction, also line of sight. The problem I've got, especially with that last one, is that line of sight. People say, oh, you use sight, a verb, seeing. Okay, but yeah, we're talking about line of sight. So again, you can use any of these. The idea is to get the notion inside your head of what the definition is. You can use any of those definitions to a certain degree, depending on the context. Okay, so what are the conclusions? Here they are, conclusion or of direction, okay? Static concept, okay, first of all, it's not a dynamic concept. It's qualitative, okay? Doesn't belong in math. Only quantitative concepts belong in math, okay? Continuous, it's made out of a single piece, okay? It's straight. You could maybe replace it with an edge or an axis. Make sure you are very much aware of the context there. Okay, if you're going to use the edge of something to say, okay, that's my line of sight, that's my direction. Okay, be aware of what edge, the context of edge and axis. Okay, straight, yeah, it's got to be straight. Okay, distance, it's essentially distance with an arrow. Remember what distance was? Separation between two objects. And you maybe illustrate that with a line, two-dimensional line, right? Segment. Okay, not a 1D line, it's a 2D line, okay? That's all you can see, okay? And we put a stick there, we call it a line. And if you put an arrow, well, that's direction. Okay, see how simple it was? and requires two objects. They have to be, facing one face versus the other face. In that sense, face facing face, face against face, face opposite face, and no direction between concepts. You cannot say, well, I'm moving in the direction of intelligence or of love. No, there is no direction between love and intelligence. Okay? So when people say time moves in a certain direction or forward or whatever, or you have counterclockwise or clockwise direction, no, you got to point to something, and then you have direction, and you can't point to something if you're turning the corner. Okay, then you're not pointing to that same something. Okay, so you cannot say that a curvilinear itinerary goes in a given direction. It doesn't. In fact, it's changing its direction every location, and that's what they call velocity at each one of those points. And the whole thing is called acceleration if direction changes. So that's something for you to sink your teeth in now. Okay, let's go with our science critic. And here we have another person who has problems with semantics, word salad. Let's see what he's got to say. And he's going to say here essentially that science is about winning arguments. Winning arguments? In other words, you have a discussion with someone else, and if you win the argument, maybe because you beat them up finally, then you're a scientist. That's more or less what he's saying, okay? And of course, if science is like law, where you have a prosecutor who's trying to convince the jury, lawyer out there, well, then you're going to need evidence, right? That's one of the issues that you're going to present. And the other one is that you're not going to allow the defendant or the defense attorney there to change the words, the meaning of words, because you're going to accuse them and say, oh, you're changing the meaning of the words, instead of murder, you call it manslaughter. You change the definition here on us, right? And so, yeah, then you're going to win the case just because you changed the definition of some word. So are we not allowed to change definitions, especially if the traditional one that we use, the one in ordinary speech, is irrational and cannot be used in physics? We're not allowed to change that? It stays like that forever because that's the way our forefathers defined it and used it, and that's the etymology of the word, etc. Okay, let's listen to him. Let's see what he's got to say. Here it is, our science critic, fingernails. Okay, give me a second here and put them on. Go. The questions and issues to be addressed in this rebuttal include, is science about winning arguments? And is defining words rationally nothing but a frivolous exercise in semantics?
Bill Gates is doing the exact same kind of thing that flat earthers do. He's not trying to win the arguments based on evidence. He's trying to win the arguments based on semantics. When you try to redefine the entirety of science to work in your favor, then it becomes a lot easier to win the arguments.
Okay, so science is about winning arguments, and for that you have to present evidence and hopefully change the words on the scientists so that you mix them up and they say, oh, you're not allowed to do that, Bill. You can't change the definitions of words. Those are your definitions. Of course, if you change the definitions, you're going to win the argument. That's their rationale, okay? And so here's kind of like the conclusion of what this fellow said. Science is winning arguments. So I'll let you figure that out if that's what science is about. In other words, science is persuading, convincing, converting, and recruiting. That's what this fellow is essentially saying. Okay, if that's what he thinks science is. And of course, if you're going to do that, if you want to win the argument, of course, you're going to present evidence like they do in law. The prosecutor brings in, the evidence to try to persuade the jury to believe in his side of the case, in his theory, in his in his argument. And of course, if he changes the definitions, he's got a better chance of winning the arguments. And so it says, "Oh, Bill, what you're trying to do is change the definition so you can win the argument." Well, we're not into winning arguments. We're here to explain mechanisms so that you understand a new mechanism of how the universe works. And that is that there is no action at a distance, essentially, and that everything in the universe is physically interconnected. All atoms are connected. So that's the assumption. With that, we explain electricity, magnetism, gravity, etc. Okay, and so the issue here is that we define words because they redefine them, right? Because they've never been defined, actually. Not for the purposes of science. They've been defined for the purposes of ordinary speech. The mathematicians bring them into science without any scrutiny, and so they start using these words. Yeah, an object is that which you can see and touch, and they don't even pay attention to what they said, partly because they don't need objects. They replace every object with a point because they're looking at mass or something else. And so they don't, or a particle, and they say a particle is just a dot. Just imagine a dot flying. It's got mass, it's got charge, whatever. And so they absolutely don't need the objects. And so there are no objects in mathematics, mathematics or mathematical physics for that matter. Neither one has objects. They don't need objects. They work with points, which supposedly are locations, which are not even locations. What they are is positions, and positions in ordered pair, and so on down the line. So it just goes on and on and on. You never have a physical object. Okay, so they never define words because they never needed to define words, not if they're going to give a physical interpretation to their equations. Okay, and so all we have is irrational explanations, physical interpretations today, because all they want to do is win the argument. And when you put them against the wall and say, well, that's irrational, and they say, well, we don't understand it either, but we proved it. Oh, you proved it? How did you prove it? Well, because computers wouldn't work if particles weren't at two places at once. And GPS wouldn't work if we could not bend time. Those are the types of answers you get from them. And so, yeah, we have to redefine these words. We have to find out what these words mean because we're communicating our theories, our physical interpretations. And if physical interpretations are part of philosophy and not a part of physics, why did the so-called mathematical physics, why did he attempt to give a physical interpretation to his equation? I mean, if he stayed completely within his world of numbers and equations and formulas and so on, no problem. He can do whatever he wants in there. But he wants to give a physical interpretation to his equation, for otherwise his equation is irrelevant, has nothing to do with reality. It's just a description and not an explanation. Okay? Okay, we have a couple of people who made some comments, and one fellow says, does Norman Wildberger's rational trigonometry have anything to do with rational science? Well, let's look at that word trigonometry. Okay, that's the one we're interested in because he's talking about trigonometry and he puts this word rational in front. Okay, so let's first find out what an explanation is. Okay, and so here you have the word explanation according to us. Okay, the causes or reasons in the case of philosophy, right? But physics is causes underlying a phenomenon. That's what an explanation is. Okay, that's what we use for physical interpretations. Okay. And another definition, how mechanisms, physics, or why in the case of purpose, in the case of philosophy, a consummated event happened. Okay, an explanation deals exclusively with the past. Okay, and then what is rational? Well, we needed to define rational because everybody wants to think of themselves as rational. But then they say irrational things. They start using words like plasma and ether and energy and wave. These are irrational terms, especially when they're used. They're irrational because they've never been defined concisely, perfectly. and rigorously, and then on top of that, the worst problem is that they use these concepts as physical objects. So that's why they're irrational. So that's the main problem. The main problem is treating concepts as objects, as things. They start moving these concepts around. They move all these souls and conscience and energies and fields around. And that's very scary. It's like moving their intelligence around, whatever intelligence they have. Using inconsistent definitions or undefined words. Usually, in fact, I think 100% of the time, not usually, but 100% of the time, it's all these words that we've inherited from our great, 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 great grandfathers who misdefined them from the start because they had no idea what they were doing. And that's what we have in the dictionaries today. Theory is inconsistent with or doesn't follow from the assumptions. Okay, you make an assumption and then theory has nothing to do with it. The prosecutor presents a knife, says, okay, this is how the person was killed. And then during the course of the argument or trying to convince the jury, he says, and the poison entered the person's body. Poison? I thought you said he was stabbed or she was stabbed. So the theory doesn't follow from what the evidence he presented, the assumption he presented. Okay, describing and claiming to have explained and mechanism proposed doesn't work or cannot even be imagined. Okay, God trying to make a square the circle, so to speak. Okay, so trigonometry first is not an explanation, and then trigonometry is full of lots of words that I think are not well defined. Okay, as long as it stays within mathematics, we don't care. But don't bring trigonometry into physics. And geometry was the first religion because it was an attempt, in fact, more than an attempt, to merge math with physics. They had the physical world that they measured, and then they looked at all these angles and so on, sides, and try to make sense of that physical world. And of course, they invented all these abstract objects, such as point, line, planes, and solids, etc. And then they looked at angles in there, angles and lengths of sides, and all this kind of calculations that they did. The calculations are okay, but then. And if they would have stopped there, then it would have been okay. The problem is then you get people like Einstein who says, gravity is geometry. Oh, why is it geometry, dear Einstein? Well, because, see, we have this space-time thingy, four-dimensional thingy that we cannot imagine, cannot visualize, and it bends. Well, how do you know it bends if you cannot even imagine? If you cannot show me a picture of bent space-time on the screen of your 4D, not the 3D, not the 2D. I want the 4D, the one that you said space-time is. I cannot imagine, he says. Okay, so we have a problem because suddenly geometry enters the world of physics and these people are trying to explain gravity with geometry. That's where we run into trouble. That's where we have irrationality. Okay, and so you got to be careful with trigonometry only if you try to introduce it into physics. We have no use for numbers. And we're going to talk about angles at another time, but angles are not what these people say are angles. Again, dynamic versus static concepts. Okay, and here's another fellow, and he says the following, says, all satellites are on balloons. And so you go to this site. I didn't put the site there. It's a YouTube site, but look up that title and you'll find it. And they show that this transporter of some kind takes this, I think it's 8-ton, maybe, I can't remember now, but satellite, and they show how the balloon that you see on the right pulls it upwards. And this guy thinks that because of that, all satellites are on balloons. That's his argument in the video. Okay. Well, yeah, so these people, again, they think that satellites are just being held by little balloons. Oh my God, what a world we live in. And you tell me that it's not the end of the world. Yeah, sure. Okay, and here's another fellow says, you need to tell us how exactly every atom in your body could possibly be bound to every other atom in the earth. Do you have any idea how many atoms there are in the earth? Uh-huh. What about in the universe? Man, that's a lot of atoms. Your model is illogical, irrational, and downright impossible. Okay, but we only have one, and that's a single thread there. That's all we have. So that's quite simple. One, the nomad. uh, we have only one, but forget about that. He's contradicting himself. He doesn't even realize it right there. He says, you know how many atoms there are in the universe? Uh, no. Could you please tell me? And I guess he would say, well, it's impossible. It's impossible for there to be so many atoms in the universe. But he says like he knew how many, like there's many. There's tons and tons and tons and gazillions of atoms. So what should I answer him? That's impossible. There can't be so many atoms in the universe. Right? Is that my answer? So he doesn't think there's that many ropes because there's, you know how many atoms there are in the universe? Yeah, there's many, many atoms. And so there aren't that many atoms in the universe then, because I cannot imagine that either. So I don't know what's going through this person's mind. But yeah, our basic hypothesis is very simple. There's a single thread. Now that's one. Closed loop thread, okay? Can you count to one? That's how many there are. Okay, with that, I'll see you next week, and we'll continue with this line of questioning. We'll see you then. Bye-bye.